Hey, hello everyone. Today is February 12th, 2020. This is the data protection working group meeting. So this meeting will be recorded and uploaded to YouTube. I'll be hosting today's meeting. Sean Chen will be the co-host. Let me share my screen. So today we have a few things in the agenda. So Ben will go over his implementation of the data populator. He did give an overview last time. And then I will talk about the work on execution hook. And then we talk about some activities at KubeCon Amsterdam. And then we have open discussions. Okay, now we can start. I'll stop sharing. Ben, if you want to share yours.
Well, yeah, I was going to say I wish I had time to cook up some slides with some pictures of how this works, because I don't have that as of yet. But we can talk through the code and/or the implementation, and hopefully there's questions about the details that we can actually make some progress on. Maybe coming to an agreement about how data populators should work, or at the very least getting people to think about the details so that we can have that discussion later. So just briefly to recap, I guess it was 2 weeks ago, I did create a KEP for data populators because I do believe that however we end up implementing backup and restore, there will probably be a CRD in Kubernetes that represents the backup object, and the restore will probably involve some creation of a PVC with a reference to that backup object, presumably as a data store. And today, Kubernetes doesn't allow you to put CRDs in the data source field that are not either an existing volume or an existing snapshot. And there are designs in which this won't be necessary, but I think it's highly likely that we will end up needing some new CRD for a backup, and we will need a way to specify as a data source in Kubernetes. And so I have the KEP to basically just change the Kubernetes API to allow arbitrary CRDs to be data sources. And so what we didn't get into during that meeting 2 weeks ago was exactly how this might work at an implementation level. So I'm trying to think what I have other than the code that I could show you. Yeah, it's tricky to actually do a demo of this, but the code is there. It's not that long. I simplified it down to the minimum necessary, but mostly I'll just talk
Ben,
through the details of how it happens.
Hey Ben, can you share your screen so that people can sort of follow what you're talking about?
Well, if we want to go through the code line by line or function by function, I'm happy to share like the GitHub repo, but like I really don't have any slides or pictures, and I really wanted to start by talking through what actually happens in Kubernetes.
So maybe just put your KEP on the screen so people have something to look at, rather than right now there's nothing on the screen to look at.
Yeah, how could I find that KEP?
Okay, I can just.
Do you have the number?
Yeah, let me do that.
I don't have this. I use my Windows laptop for these meetings, and I never use the Windows laptop for anything else. It's just for meetings. So I unfortunately have no bookmarks on it.
Yeah, you can go ahead and talk. I will just open that up.
KEPs, SIG storage. Oops, that's the wrong one.
No, I have it actually. I can just show that.
I managed to get it here.
Okay.
Share. Yeah, so this is oh no, I can't see anything. Yeah, this is the KEP for data populators. So the main issue is that right now, if you put something other than a volume or a snapshot in the data source field of a PVC, the validation code in the Kubernetes API server just drops it. And what you end up getting an empty volume as if you had never specified a data source, which by itself is a weird behavior, but we want the ability to basically experiment with doing backups and restores through CRDs and doing other forms of data population through CRDs, which is out of scope for this group, but it is a sort of a parallel goal of mine, is to enable any kind of data population through CRDs. So the Kubernetes change is very simple. It will be a new alpha feature gate. I'm not sure exactly what it will be called. We'll have to decide that in the coming weeks. But when you enable this alpha feature gate, it'll basically stop deleting CRD references on PVCs that are not snapshots or volumes. It'll just leave whatever object type you put in your data source field of your PVC. So that has two implications. One, the thing that currently looks at that field is the external provisioner sidecar that we all ship with our CSI drivers. That code, if the field is empty, it asks the CSI driver to create an empty volume, as one would expect. And if it's either a volume, if it refers to a volume or a snapshot, it requests a clone of that volume or snapshot, respectively. Fortunately, if you put something in there that is not one of those two things, the sidecar looks at it and says, I don't know what that is, and it just doesn't do anything. It just waits, which is the correct behavior from my perspective, because what you want is to be able to add new things. And if the provisioner side, if there's not a feature in CSI that knows what to do with that, then the external provisioner sidecar shouldn't do anything with that. So my proposal for the sidecar, I'll pull up the code real quick here and show how this works. It's called hello populator. Okay. Yeah, so everything here is in this one file called controller.go. It's only about 750 lines. It's not terrible. And this is heavily based on the sample controller that exists in the Kubernetes tree today. So if you're familiar with how the sample controller works, this is not a huge deviation from that. So what this controller does is it basically follows the same basic logic as what the external provisioner sidecar is doing. It's watching for PVCs. When it sees a new PVC get created, it goes and figures out if there's a bounds PV. And if not, and if the data source is something that this populator understands, then it says, okay, it's my job to create the PV that this PVC will bind to and then perform the binding. Of course, this thing doesn't have a CSI driver. It doesn't have access to any real storage, so it can't create a PV on its own. So the approach that we use in this example populator is you create a second PVC with all of the same parameters as the one that the user created, except that the data source field is empty. And then the normal CSI controller for that storage class will see that second PVC and say, oh, I know how to address this one because there's no data source, so I need to create an empty one. And it will provide an empty PV with all of the same parameters that the original PVC asked for, just no data in it. This populator does that in a separate namespace because I don't think it's a good idea to have extra PVCs popping up in the user's namespace, because the user could see those and wonder what they're for. So this has its own namespace where it does all of its work. So it creates a second PVC that's exactly like the first one, except no data source in its own namespace. The CSI controller will create that, and so it waits for the PV to exist. Then it creates a pod, again in the other namespace, attached to the PVC and writes some data into it. And in the case of the hello populator here, it just creates a file with some text in it as an example of a way to populate some data into a volume. And so the implementation in the hello world populator is it's a naked pod that's managed by this controller. And so if there's any failures or anything, you'd have to delete the pod and create a new pod and repeat that process until it eventually succeeds. You could also use a Kubernetes job or other, there's other higher level abstractions that would sort of enable you to ensure that the population process was complete before you went on to the next phase, which is to take the PV that now exists and has the data in it and rebind it to the end user's PVC. So
Hey Ben, I remember one version of your CAP actually described how this worked. Do you
yeah.
still have that?
Yeah. So originally I wanted to propose this full implementation of how data population should work as the KEP. But the pushback I got was, all we really need on the Kubernetes side is to change the API, the Kubernetes API, because all this, the machinery that for the data population is out of tree. So rather than define a solution in the Kubernetes KEP, just limit the KEP to the Kubernetes API change and then figure out the machinery to make it happen out of tree in this working group or SIG storage or however we want to. I mean, there are a few different ways to actually make this happen. And so, this is the prototype I came up with, and it works pretty well.
Yeah, Ben,
yeah,
I've got one question for you, if you don't mind. And by the way, this is completely the path we went down as well, also, as we talked about offline. But so you are relying on the fact that there is a data source that is unknown by the external provisioner to keep it from provisioning against the original PVC, right?
Well, yeah. So any CRD that is not a snapshot or a volume will be ignored by the external provisioner today.
Right.
Now, one could presume that in the future the external provisioner will get smarter and will know how to restore from other things. But as we design those other things, like if one of them was a backup, for example, you could have it be smart enough to look at the backup object and decide if the CSI driver should do it or if it should leave it for some external controller to do it. So as we add new objects to CSI or new ways to restore data through CSI, we'll have to evolve the provisioner sidecar to know what to do with those. And right now it always just, if it's a volume, it always says clone to the CSI driver. If it's a snapshot, it always says clone. But you could have more complicated logic to say, well, if it's a CRD and this field is set to true, then do it through CRD. If it's set to false, don't do anything, or something more complicated.
So it sounds like data populator. The plan is that there's a second operator that's watching for PVCs, and if it sees something that it understands that it thinks CSI doesn't understand, it goes ahead and starts doing things. Is that the deal?
Yes.
How about as we evolve CSI, so as we add additional data populators into CSI, how do we signal from the CSI driver to the external populators, because there's probably going to be a bunch of them, they may not all be in sync, that, hey, I actually grabbed this. Or in fact, if you have multiple populators running.
Okay, I solved that problem at least once, and it's not here in this example. So I'm happy to talk about that because I think it's a solvable problem.
I think it's a solvable problem too. I think I was just asking, is that on the plan? So that should go into the KEP, right?
So for some types of things, I think it's safe to assume they will never be built into CSI, like this hello world thing, right? This is a CRD I made up. It does something silly, but something like this could have use to somebody, right? Somebody could design their own CRD and says, I'm going to use this to populate my data, and as long as it's not like a standard that's been agreed to by SIG storage, it's never going to end up being handled by the CSI sidecar, because the CSI sidecar will only ever deal with standard things that we've blessed.
Sure, but we can start with, say, an S3 object, right, which starts out as a data populator external, and then we bring that into CSI.
Okay, yeah, I see what you're getting at. You're imagining something that will eventually be standardized, but in the initial versions is standalone. And then you're worried about how does it evolve into a situation where CSI does handle it and there's no conflict.
Kind of standard populator that multiple drivers could end up supporting. How do we say which driver gets it?
Okay, that could probably be handled through versioning. Like the first versions of it that you implement might be alpha, and then you could teach the external provisioner never to deal with the alpha versions of those objects. And then by the time it got to beta, you could say, well, you better have solved the problem of how the things cooperate. I think that, there are ways to sort of put a proposal out there that you hope will eventually be the standard, and then implement it on the side for the first version, and then eventually evolve it into being handled by the standard sidecars.
Yeah, specifically, I guess what I'm asking, and I don't know if it's the same thing that Dave was going down, is this strikes me as a point at some point there where you're going to want to have some level of, I don't know if indirection is the right term, but the way we have with the class thing where you identify which one is going to handle this.
Okay, so let me tell you what I did for my prototype with backup and restore, and see if that sounds appealing to you at all, before I go on to cover the details of how this actually works. So my backup CRD had both a restore field, which is similar to like the CSI driver field, so that if you have multiple CSI sidecars for different CSI plugins, they know which one should so they already look at that, right? If you try to restore from a snapshot, the provisioner sidecar will look at the driver field of the snapshot object and say, if that's not me, I'm not going to handle it, right? Because presumably someone else knows how to do that. So the CSI drivers already know which driver, the sidecar knows which driver it's dealing with, and will filter on that driver when they're looking at these objects. So what I did with backups is I added yet another field, which was the format. So every backup object has both a format and a restore. And one of the new CSI endpoints I added for my prototype was like get supported formats. So what the provisioner would do is it would talk to the CSI driver and say, what formats do you understand? And it would return a list. And then when it saw a request to restore a backup, it would both filter on the restorer field. And so if this restorer doesn't match the driver, I'm going to drop it. It would also look at the format and say, if this format is not one of the supported formats, I'm also going to drop it and let someone else deal with it. And in that way,
So Ben, go ahead.
So the current thing is the proposal is the KEP currently is very narrowly scoped. It's get rid of the restriction.
Yeah.
And then we're going to have to do a second. You're going to do a second one that's actually how this is implemented. So we can probably table or open up these things later on. They're not really
well. So to be clear, I think this KEP is accepted, and we're going to implement it and put it in alpha. And then part of the graduation criteria for the KEP is before we move to beta, we have to figure all this stuff out. But I don't think that there will be another KEP. It'll just be, we'll have to figure it out.
It's going to become a much bigger KEP
somewhere. Well, but this is all out of Kubernetes. This is all out of the Kubernetes tree. We need to have a solution for SIG storage that's implemented in the sidecars and that the storage group agrees to. But Kubernetes doesn't care about any of that as long as we're happy with it and we move it on to beta, and then it becomes something that's enabled by default. So I don't think there will be another KEP, and I don't think there'll be a lot of changes to the KEP. I think that what's needed is us agreeing or coming up with some design document that's SIG storage specific. And I don't know if a KEP is the right way to do that.
Ben, does data population work in concert with the provisioner? So from what I understand right now is that we're proposing that if a data populator is set, then the provisioner stops there. The data populator kind of takes over, creates.
If the data source is set to something it doesn't understand.
Correct. It's set to something it doesn't understand. It doesn't move forward. The data populator then, in this proposal, for example, creates another PBC, which doesn't have any populator set, and kind of goes from there. Mm-hmm. I'm wondering if data population actually needs to work in concert with provisioning, where you don't actually need to be creating any dummy PBCs or separate PBs.
Sure, that's the case where the driver understands the source. That's why he keeps saying source, not populator.
Well, but you can also you could have the driver, for example, delegate. So the CSI driver could say, I understand how to make a volume.
Yes.
but I don't understand how to populate it.
Exactly.
So
And it could go ahead and write a CRD saying, please populate this volume with source X.
Right. And then I can move forward with the rest of the provisioning once population is done.
I think that in John Griffith's original proposal, the provisioner actually is involved. The provisioner will be creating an empty volume, and then
Yeah,
the data populator will be populating data to it.
But the populator is calling the provisioner to create a new PVC and a new volume, and then it's going to swap the PV in.
Yeah, so let me describe the rest of the process, and there's some subtlety here, because you're right. We had some earlier proposals, but the issue that we always came to was typically after you have your empty volume and you're ready to populate it, you want the thing that does that work to be a Kubernetes pod, right? It's weird to do it. If you're in a Kubernetes cluster, it's weird to do that any other way.
Right.
But
well, there's a lot of other things that could be happening. I mean, the storage system can do it itself.
oh yeah, right. For the things storage system can handle itself, that's great. But like for all the reusable populators, that we probably going to want to implement those as Kubernetes pods that know how to talk to PVCs. And there are many use cases of reusable populators that are not going to be CSI specific. I mean, for all the CSI specific stuff, I'm perfectly happy to say, yep, that's a CSI thing. Add new CSI, modify the CSI RPCs to do it. But I'm interested in and we specifically call these generic populators because they're not platform specific. That's very important. Is that there's a huge class of non-storage specific populators where I just want to have data on my volume and I don't care. You know, I just want it to work on 100% of CSI implementations. The issue is if you just create one PVC and create a PV and you allow it to bind, at that point, if the user had created a pod attached to that PVC, the pod will say, I can run now, right? Because the PVC is bound, but there's no data at that point. So
I think what I'm thinking is that you could hand off the PV before you bind it to the PVC. So you hand off the PV to the populator.
Right, but the way I do that is with a second PVC, because that's how Kubernetes works, right? If you want to have a pod and you want to attach it to a PV, you need a PVC, and you don't want it to be the PVC that the user created. Therefore, the second PVC.
But your workflow right now is the CSI driver basically gets out of the way.
Yeah.
And then we kind of come back to it. Hopefully the populator wakes up and creates a PV for you and calls a CSI, creates a new PV in its own PVC, populates it, and then how does it get back to the CSI driver or the original PVC? It goes and mucks with the
CSI driver doesn't have to be involved at that point because it's just a binding problem.
My audio dropped out for 30 seconds or so. I'm sorry.
But then, so the data populator is responsible for doing the rebind.
It doesn't have to be. As long as it sets it up so that it follows the rules necessary, the storage controller will do the binding.
Well, then the storage controller needs to know when it's done, right?
It just needs to have the binding logic be valid. And so you've got to, yes, you need some status to reflect that.
Yeah.
But
and that's actually just why I brought it up, because you were asking whether there'll be a second cap, and what I was thinking was we'll need something to describe that.
Well, you guys are talking as if rebinding is very hard to do, and it's not.
No, but you have to define the workflow so everybody does it right, and the people know what to do when they're implementing this.
Well, okay, yes. So maybe it would also help to cover some of the other ideas that we had initially, and why we didn't end up implementing those. So we did consider an idea of keeping the one PVC model, but putting a taint on the PV, and then implementing that would inhibit the original user's pod from binding to that PVC until it was populated. There are no taints on PVs in Kubernetes today, so we considered adding that as a new feature that will be generically useful, that you could taint your PVs so that ones that were awaiting population would have a taint on them that would inhibit everything except for the populator pod from attaching to them. But implementing taints as a top-level Kubernetes feature on volumes is a massive undertaking for somebody, to define a whole new taint toleration API for pods and PVCs, and so nobody wanted to take on that large amount of effort. Although I think it would have solved the problem. The other thing that was considered and rejected over a year ago was some sort of a PVC swap API that you could call, where you could have two different PVCs and two different PVs, and you would invoke some operation. And we never defined exactly what it would look like because we couldn't figure out, how to do this through Kubernetes declarative API style. But some general way of swapping the two PVs and their PVCs to basically have a standardized way of rebinding two things. The two problems with that approach were, one, we couldn't figure out what the API should look like because Kubernetes is declarative, and this is a very imperative type of request. And two, there's all kinds of scary things that happen when you rebind PVs and PVCs if they're attached to a pod at the moment that happens.
So I think we're talking about two different things, because you're talking about things like the PVCs being rebound, and I think I'm with you on that. But I'm talking about the control flow and who knows what's happening.
Okay. Well, yeah. So again,
for example, like when you started with this, you said that one of the current problems is that if the data populator has something weird in it, you just wind up with an empty PV. So, and you would like to have some error reporting. How are we going to do error reporting?
Hold on. There's a separate problem. So today, without the alpha feature gate that I intend to add for my KEP, the way Kubernetes behaves is, it just drops it, which is just a bad design that is regrettable, and when we're in the process of fixing. I don't think there's any argument that that we should have done something other than just drop it. But
so for example, say you get into this situation where you put in a PVC, it has a populator that's type X, which another populator needs to handle, and
data
the CSI
source.
driver.
Please say data source, not populator.
Okay, data source. The CSI driver looks at it, says, "Nope, I can't handle that.
Yeah,
I'll wait for somebody else to do it. That's fine." Then the data populator for that, or the data source for that, picks it up, goes to create a new PV, and the storage system says, "No more space."
Yeah.
So then, where do we wind up?
Then it just hangs until you get more space, which is exactly what would happen today, except you would get a useful error message too.
Right. I think the useful error message is kind of key for everybody.
Oh yes. So I agree that there are problems with propagating error messages back from the temporary PVC to the real PVC, and there's a separate problem, which is what if the populator never got installed? You'll just sit there and wait forever.
So that's what I was thinking. On the control path, you might want to have it where the driver actually drives it, where the driver says, yes, there's a PV that I need to create. I don't know how to fill it in. So I'll go ahead and do the logic of creating the PV. And if there's an error, like I'm out of space or something, I can then generate it. And then after I've created the PV, then I can tell the data source to go and fill it in.
Well, so you're right. We could enhance the interaction between the external provisioner sidecar and the CSI driver to have a new kind of creation request that says, please create me an empty volume, but don't just make it ready to use. Like, we're gonna hold it after it's created and go do something else. And all the regular errors would still flow back as errors, but success would be delayed until we did the other thing. The problem is the other thing is generally going to involve like creating another pod and attaching it to that volume. And so I don't know how to do that without a second PVC.
I'm not having a problem with the second PVC.
Okay. Oh, okay. So
I'm just saying what your control flow is should we look at? I'm saying let's look at the control flow.
Okay. Well, so the way it works today, if you look at the hello populator, let me scroll down here, get to the interesting part. See, we can have all these informers. We have a run worker, sync PVC. Okay, here's sync PVC. So this, we have data source. We check what the kind of data source is. If it's this only deals with things called hello. It gets the thing. It looks for the pod. Looks for the second PVC. It runs the pod, and then Where's the success case? Here. Oh yeah, checks if the pod has succeeded. And then, okay, so basically we had this control loop where it's going to keep watching the original PVC, the temporary PVC we created. It's going to watch for the PV that the Sidecar creates. It's going to watch for the pod that it creates, and then when the pod eventually succeeds, the second PVC has been created. It's been bound to a PV. The pod did its job, meaning the data is now there. At this point, we need to rebind the PV back to the original one. Now, this particular implementation actually creates a second PV and binds back to the first one. This is not necessary. You can just take the original PV and rebind it directly back to the original PVC. And Kubernetes is perfectly happy with that, I discovered. So there's actually a few different tricks you can play to do the rebinding.
I was going to say, Ben, what you can do, right, is you can put just the back reference in the PV and leave the completion of the binding up to the storage controller, right?
Exactly. Yeah. So the moment that we set the back reference correctly, we can at that point go delete our temporary PVC and our temporary pod and remove all the finalizers and walk away and let the ordinary volume bind controller do the binding and then make the user happy. So yeah, as soon as we update the PV to point back to the user's PVC, this controller just needs to clean up and it's done.
Hey, Ben, just your time check. We do have other items in the agenda.
Okay.
So
Yeah.
now
Well,
okay.
this kind of covers the main thing I wanted to cover, and I think the discussion is productive.
Can you actually put all this together in a document so people can go back and read it? And
yes, I absolutely can. I'm not sure when I can do that.
Okay. Yeah. So whenever you get time, I think that will be helpful. Because
sorry, before we end, I have one last very quick piece.
okay.
If the external provisioner is not in the picture, I don't know how effectively we can handle topology and a delayed binding.
Yeah, there could be weird corner cases around certain types of provisioning workflows where this doesn't work as well. I would have to think about things like the delayed binding ones. I did not think about at all.
So I thought the delayed binding is basically gets written as an annotation. The location of it gets written as an annotation by that top level controller. So
right.
The location of where to provision it is known, so that when you ask for the provisioning on your temporary PVC, you can put that same annotation in, so that when that one gets provisioned, it gets put on the right node.
Right, but your data populator will need to understand that piece of logic as well. That's what I was saying.
Ah, right, yeah, the data populator, but I don't think that it requires any change to the external provisioner, I guess was my point.
Yeah, yeah.
So there's logic in here somewhere that actually creates PVC prime, and I'm not finding it at the moment. But it basically just copies the whole PVC. So yeah, if there was annotations on there or anything other than data source, I think they would get copied to the second PVC, and it would be.
Sorry, Shane. We can keep this offline. Sorry, Shane.
Okay.
But somebody raised the point about like better managing the, when this is done and doing the rebind, and it's possible that some of that can be standardized. I don't know if it needs to be represented in the library or in an API, but yes, those are the details that we totally want to iron out and agree to before we move forward with, making this beta, and we have time to do that, right? It's not even alpha yet. So we have at least 3 months to come up with a good design for that finishing off the workflow and handling all the weird error cases. What if the provisioning fails? What if there is no populator? You got to return something. Those details need to be worked out to have a very smooth user experience.
Thanks, Ben.
All right.
So
okay.
We can come back to this.
Just one thing, Ben, your CAP says specific design of how a data populator should work will be handled in a separate CAP.
It says that?
Yes, under non.
I do think this needs another CAP.
Okay.
Even if the code will be in the external repos. Yeah. Okay,
Yeah,
so
it needs to be,
we'll come back to that.
the specifics need to be handled in another design. Whether that's a
Yeah.
KEP or not is debatable.
We can decide that later. So definitely we at least need some type of document so people can review it, right? Not just code, right? Okay,
Absolutely.
so we'll go back to that. Thanks. Okay, now the next topic is execution hook. I'm going to share my screen. Okay, so we actually have been working on this for quite some time now. Well, the motivation is this is after we have added the snapshot support. We don't have a common way to quiesce the application or unquiesce when we do a snapshot. So the purpose for this execution hook is provide a way to do that so that we can have application consistency. And the status of this work, we do have a CAP, so I have a link here. The CAP was actually merged. And then implementation is in progress. So Ashish has been working on this. But then we got some comments from API reviewers. They give some suggestions, but then that actually means we'll have to go a very different direction. So actually during the design phase of the CAP, we actually look at several different approaches. So there are, of course, there are many different variations of it, but mainly there are two directions. One is proposed in the current proposal. We will have a CRD that defines the hook. And we also have a external controller to manage the lifecycle of that hook. And then in the alternatives, we will add those hooks inside the container itself. And then, of course, there are different ways of how to trigger that hook. It can either be run by the kubelet or it can be run by a external controller, application snapshot controller.
I'm sorry, when you say add the hook to the container, what?
I can show you later. Yeah, so I have some details later on. So basically, it's going to be a handle. So just like I can show you later. It's in a later slide. There are details there. So it's inside the container, basically. Okay, so this is the current proposal. Well, we have two CRDs. One is the execution hook. So inside this execution hook, we will specify the pod and containers where you want to run this hook. And then there's this hook action name. And inside the hook action CRD, we define what type of command you want to run inside the container.
So there are the container, yes, that runs the application, or different.
So this can be either way. So when I did my POCs, I just have this one container, but you could also have a different one.
Okay.
A special one, I think is possible. So here we have in this diagram we show two controllers. One is this execution hook controller. Another one is this application snapshot controller, which actually there is another CAP that Inan has been working on. We actually should have asked him to talk about that as in one of our meetings. So the application snapshot controller will be taking a snapshot of a whole application. So here we have a execution hook CRD, and that's the green box here. And then we also have this hook action. Hook action user will be creating those so that it can be reused. In those hook actions, you define the type of commands you run. And the application snapshot controller will be the one that creates the execution hook. And then the execution hook controller will be the one that manages the life cycle of it. Basically, there will be, based on the whatever is in the hook, it will be running that trigger the execution of those commands. So this is any questions on this one? This is the current proposal in that cap.
Quick question. Your
Yeah.
execution reference to the hook action, or they just copy it into it?
Yeah, it's actually basically kind of so there are different proposals. One way you can just reference it, but you can also copy the whole content, and then so basically they'll be the same. So whatever is in the hook action application snapshot will know what are the commands that is needed.
Hi, I have one quick question.
Mm-hmm.
Is there any particular reason these two are different resources? I mean, is there expectation?
Oh, the hook action and the execution. Yeah, I think initially it was together, but I think this is mainly for so for example, if you look at this hook action example here, right? So I said, okay, this is like a script that I run for MySQL, but it could be some other, like the MongoDB, there are certain commands you run to quiet. So those type of comments can be shared. So that's why we thought, okay, maybe it's better to separate them. This way you can create those hooks and then it can be used later by other, this hook action can be used by other execution hooks. So that's the reason that we want to separate them so that it can be reused.
Okay.
So I got a question. So
Yeah.
how do you define the action timeout time? Because in reality, that if you want to do a snapshot for an application, it's hard to estimate how much time that it takes.
Yeah, I think this is for the quiet itself. This is how long you wait for, because what if it doesn't come back? For some reason, you said you want to lock the tables, but for some reason it takes longer.
So basically, user they need to figure out what is the best timeout for the application.
I think yeah. So user who knows the application, will be define those timeouts.
Okay.
Yeah, actually, with respect to timeouts, two things. One is, if it does time out, is there an expectation that it's going to undo the action?
Yeah, so those we actually have some details in the cap. Basically, yeah, if it's really times out, then you can't, of course. You can't wait there forever, right? So because I think it really depends on what kind of problem it is, because if it's
right,
just
but
not
if I
possible
time
for
out,
you to.
well, no, but I say quiesce something,
Mm-hmm.
and I'm waiting 10 seconds,
Yeah.
and it doesn't happen. I say, okay, that was my wait time. So with the controller, then, like say the controller had quiesced 5 out of 10. Pods. Would the controller then be responsible for rolling that back when the timeout expires?
Yeah, it should, because it can't really, if the quiesce really didn't happen, it can't go ahead and take snapshots, because then it, whatever.
Yeah, the question would be who's responsible for unquiescing, or for example, like it's done 5 and it's still doing.
This will be the. So since execution hook controller is the one that is running this command, so execution hook controller will be responsible for that.
So like after 10 seconds, the execution hook controller says, no, I'm going to give you status of timed out. And then it would be responsible for undoing whatever it had done so far. So that's good.
The execution hook could describe what the unquiesce action should be, and then the controller can call that.
Right, like it would have to have quiesce and an unquiesce.
Exactly.
Yeah, so I think there is unquiesce as well. So for MySQL is actually a little weird. MySQL, but in general, yes. So you will need to unquiesce. But MySQL basically you just have this one session. You get out of that session, they just automatically.
It's possible.
Unfreeze.
And like the other problem that we've run into is we have a similar API in vSphere, and it's possible for you to like basically lock down something, but then you never unlock it. So do we have a concept of like here, you're going to lease, because it's not really quiesce, it's execution hook, which is where it gets a little weird. But in terms of like quiesce, you could see yourself having a lease, like I'm going to quiesce this, and after 30 seconds, a minute, an hour, whatever, if I don't release it, it's going to get released automatically.
Yeah, we should be able to do that. Yeah.
It's possible it needs different actions, like one for so you have your regular hook action, which we used to initiate a quiesce, and then we might need a successful completion action and an unsuccessful action, which one you would use upon where backup was completed normally, and now we want to unquiesce. The other is where we timed out, we didn't actually complete the workflow we were going to do, and we want to unquiesce, because there might be some different actions. I'm thinking of like a database that does something like truncate its transaction logs, which you would want to do at the end of a successful backup, but not do if you didn't actually complete that action.
Yeah. So actually, I don't have that in this slides, but actually in here we actually talked about like error handling basically.
There's another subtle failure mode, which is if you set a timeout on how long it can be quiesced, and your snapshot, the snapshot itself takes about that amount of time, knowing that the snapshot completed before the unquiesce happened can be tricky in a system like Kubernetes that has no concept of a clock. So you need a way to like detect when all the snapshots have definitely been taken and know that nothing has been unquiesced at that point, so that you can declare success on that consistent snapshot.
Right, so that would be inside the application snapshot controller will be the one.
But
it's
also a matter of what has priority for you as well, because you may say that my priority is having my application back up and running within 100 milliseconds, and if I miss my snapshot, I'm okay with that because I lose money when the application is quiesced.
Yes, but it's particularly challenging to know whether you hit your window or not, because different components are running on different machines with different clocks, and you need one time reference that says yes, the snapshot definitely got taken and it's not unquiesced yet, therefore I can mark it as a successful one.
Yes, definitely. And we need to have options for saying which one is more important to me, finishing my snapshots or getting my application back and running within the window.
So this action will be run by like from kubectl exec or something?
So right now I'm just talking about this current proposal, which is a external controller, the execution hook controller will be handling that. But then there is another alternative proposal, which I haven't get to yet. That will be kubeless. So there's the current proposal. Yes.
I guess Herman's question is how the execution hook controller will invoke those commands.
Yeah. So they're going to use the pod exec subresource to invoke those commands. So basically meaning that your execution hook controller will need to have those permissions to run that command. So pod has a exact subresource.
Okay.
Yeah. So I was actually trying to show that in the cap basically. Yeah. So basically, we actually mentioned that in this cap. So if the action so basically the unquiesce will always have to happen. So we actually mentioned here the controller will always have to create the execution hooks for unquiesced applications, no matter that succeeds or fails, because we can't leave it in a situation where it's freezing forever.
Yeah, just so be clear here, this snapshot controller is not the volume snapshot controller.
So the application. Yeah, we can kind of make this one vague here, but this one is actually the application. Yeah. So if you want to use it for the volume snapshot, then you can do that manually, but we didn't really intend to add this inside that. This is for the application. Yes.
Is there going to be a provision for, I mean, we talked about snapshotting and timing out as if this is all a transaction, like it either all succeeds or all fails. Is there also a mode where it doesn't matter? Like, you know, you go and tell everybody to snapshot and then you do backups and you're good as long, you know.
You're saying don't even do the freeze? What do you mean? No freeze?
Well, no, if you have multiple containers that are participating and they have multiple databases, is it a requirement that they all successfully back up or not?
Oh, I think that.
And is that a configurable thing? You know, like could I say I have an application where, well, this one I care about, and you know, if the other two fail, I can do them next time or something like that.
So make it configurable. So I think if you have, like Stefan said, you have several replicas, maybe you only need to snapshot one replica. Maybe you don't have to snapshot all of them. So I think those type of things should be configurable. Yeah,
maybe
so
those could be attributes on the action hook.
I think those should be. I think that should be application snapshot should be handling that, because the execution hook doesn't really know what about volume is involved, right? Yeah. So so for that we probably need to have the have in-and-come to go over the application snapshot type sometime. So that one, it has a view of the whole application. Yes.
Jane, I guess I have to interrupt you over here. We are running out of time.
Yeah, sure.
It's a very good discussion. Okay. I would ask everybody who is interested in the execution hook to really take half an hour to go through the CAP, and maybe you can schedule an individual session for this topic.
Yeah.
What do you say? Because we have
need to go through. We still have some other thing to finish. So so let's do that. So I can take a look. So all of this the links are in the agenda doc. Take a look. We can have another meeting to talk about this. So go back to this. Okay, KubeCon Amsterdam. So we are going to have a meet and greet at the Kubernetes Contributor Summit at KubeCon Amsterdam. So SARS as 6 storage already has this register, so we will just do it under 6 storage. So if you are going to KubeCon Amsterdam and you want to be there, this is more like a casual event, right? So as the name suggests, it's a meet and greet. So it's going to be in the afternoon of the Contributor Summit. So there will be a sign saying, okay, this is a 6 storage. Then there are a few people there. You can go there and meet people and talk and ask questions. So if you are interested in going, register for the Contributor Summit. This is on Monday, I think. This is the one day before the regular session, regular summit starts. And also, if anyone who is not a contributor, but who also want to attend this event, let me know, because I think you actually, if you want to register for this contributor summit, you actually have to be a contributor to register. But we can sponsor you if you are interested in going, but not a contributor yet. So let me know. Send me an email or Slack, or you can even add your name in this agenda doc, or your email and the name saying you are interested, but you need a sponsor to go to the contributor summit. So okay. So anyone interested in going to this?
Yeah, I'm going. I'll be there.
Okay. All right.
I'll be there too. Yeah.
Okay, great. All right. So next is open discussions. Kalicia.
Carlicia had to drop.
Oh.
So I don't know if we really have time to adequately to discuss the question.
Okay.
So this may be worth bringing up at the next one.
Okay, so we can move this to the next meeting.
Yeah.
Allow backup upgrades, but we don't really have backups yet. You mean snapshot? I mean, right now, I mean, I'm just, if we are talking about what we have in the existing Kubernetes API, right? So
yeah.
So you're talking about like if you want to do an upgrade from one version to like 1.16 to 1.17 or 1.17 1.18, how to automatically upgrade all the objects? Is that what this one is about?
I think that's what it's about, but I'm not exactly sure. So it might be better if she was here to ask. So I don't know if it was exactly about snapshots or some theoretical backup object, like say Valero or Kasten's backup.
Oh, like a CRD.
Like a CRD.
Okay.
If that.
Okay.
If we discuss like some sort of controller upgrading that, but it might be better if she was around.
Okay.
To represent that.
Okay, so we will discuss that in the next meeting then.
Okay.
All right. Okay, so we are at the top of the hour. Anything else? Anyone want to?
Jing, for topics for next one, is the best way to just add it to the agenda and then maybe send out an email if it's a.
Yeah.
Okay. We had talked when we were talking about the data protection scenarios, and also I've had discussions with Yinan about his application snapshot controller. We wanted to kind of do a quick run through of Canister, which is a project we've looked at, which actually implements something very similar to execution hooks and actions.
Okay.
So I wanted to see if we could just get the group familiar with it so we can see if we can merge those efforts, because there's a large body of work already out there that implements hooks and quiescing and unquiescing and all of the things we just talked about.
Okay, yeah, sure.
So should I just add it to the agenda?
Yeah, you can add that, yeah.
Okay.
At Webhub, can we have a smaller group ahead of time to go through the things first?
Okay,
that'll be nicer.
All right, so that's what I'll do then. I will I will send out an email after this to the group, and I will find a time where we can meet as a smaller group to just discuss that so that we don't throw off the meeting.
That's right.
Okay.
Okay, that sounds great.
Good. Okay.
All right. Thank you.
All right. Thanks, everyone.
Thank you all.
Bye.
Thank you. Valentine's Day.
Bye.
Bye-bye. Thanks, Shane.